All right, guys, we're going over the review sheet today. Your test is tomorrow. Your test is tomorrow. Tomorrow, yes. I thought you had a question. So the first thing we're going to look at is problems 1 through 4. Find the scale factor, then list all congruent angles, and write the ratio of the corresponding sides in a statement of proportionality. So this one here, we have 3 different things we're looking for. The first one's the scale factor. Now we can find the scale factor by measuring or kind of comparing the corresponding sides. So we have AB, DF, or we can say the smallest side is 5, the smallest side on our other triangle is 7.5. So our scale factor would be 5 over 7.5, but we do need to reduce this. 5 over 7.5 is this here, or if we convert it back to a decimal or a fraction, is 2/3. So the scale factor for number 1 is 2/3. Okay. K is denoted as the scale factor. I did look into it because I think one of y'all did ask about why they signified it as K. I couldn't find a real common answer for it. Most just I think they had one reference that I saw that it was in reference to, I think it was Russian or some other language. They used it for that, but beyond that, I don't know for sure. Either 1, 2/3, 3/2 is going to be the same. Now, our angles. Well, angle A is going to be congruent to what angle? Angle D. Angle B is going to be congruent to angle. And lastly, angle C is going to be congruent to angle F. Now, the similarity statement will also give this to us here because it says triangle ABC is similar to triangle DEF. The angles will match up in that there. So any questions on how we found the angles or the scale factor? Just one, because even if we find the others, because the next one we could say is 8 over 12 thirds and 12 over 18 is. So the scale factor should be similar across the board. And that's also proven when we did side-side similarity, because 2 triangles are similar if all 3 sets of corresponding sides are proportional. So this one here, you just find the scale factor. Now the last thing we need is our sides, proportionality statement. Now for this here, because it did not give us a direction from one or the other, from bigger to smaller, smaller to bigger, I just need to pick a side length to start with. So AB. And it's going to be over DE. So we're going from A to B, D to E. Then B to C would be over EF. And lastly, CA or AC over DF or DFD, as long as you have the correct side. Now, once we picked AB as the first one, the other sides of that triangle, BC, AC, all have to be on top. Since we put one on top, the others have to go on top. But that is it for one here, question number 1. Any other questions on 1 through 4? Are we good with 1, 2, 3, and 4? Yes. 3 and 4 are not any different than 1 and 2, except we have another side, another angle. We have 4 sides instead of 3, which just means that we'll have 4 sets of congruent angles. We'll have 4 sets of equal sides, but the scale factor will still be the same. Still be the same amount, same one number. So we good with these here. Questions on 5 and 6. The following polygons are similar. Find the measure of x. Well, I can look at number 5. So if we're looking for x with any of this here, we're looking at a proportion. Now, one of the numbers we're going to use is x. And I will always set it up so x is on top. It makes it a little bit easier to work with. Now, what is the number that would go on bottom? 20. X over 20. So we have our first proportion set up. Now, what is the number on top of the next one going to be? We could use 21 or we could use 18. We can use either one. We just need to pick one. So if we use 21, okay, that's fine. So then we can use 21 over 12. If they did have 18, we could use 18 over 14 or 21 over 12. Now at this point here, we can multiply both sides by 20. These would cancel. This is equal to, and at this point here, we could plug it into a calculator. 21 over, 12 times 20. Yes. And the answer is 35. So x is equal to 35. And that's it for that there. I have a feeling that the 18 was off. Nice. Yeah, that's why. Yeah, I took these off because they didn't actually continue with the proportion. Because 12 and then 20 divided by 35 is our 4/7. 12 over 21 is our 4/7. Yeah. So I realized later that the 14 and 18 didn't work. But on the test, if they are all listed, then they all do work. So that was just a goof on my part. Questions on 5 or 6? Are we good with 5 and 6? Yes. Questions on 7 or 8? Yes. No. Because we'd set up a proportion and set one of them as x, and the corresponding one to x would be 12 is equal to what? 6 and 18. Since x was on top, the side with it has to go on top. Then, since 12 is on bottom, 18 is on bottom. The proportions have to be the same. And at this point, we would multiply both sides by 12. These will cancel. 6 over 18 times 12 is 4. So x is 4. Questions on these here? And this should be 8, by the way. Questions on number 9? Find the ratio of their perimeters. Am I solving for anything? I'm actually finding perimeter. What does it say? Find the ratio of their perimeters. Well, the ratio of their perimeters is the same as the ratio of their sides. Well, the ratio of the sides is 8 to 12, which is over 3, or 2 to 3. I'll take 2/3 because it's just asking for the ratio of their sides. Find the ratio of their perimeters. It didn't actually ask us to find any of the perimeters, it just asked us to find the ratio. 27 over 30, or 27 over 50. I think that's it. Because one of those figures is 27 and 30, but the other they gave us is just 50. So we need one side and the other. Since it can't reduce, yeah. If it had been 27 over 51, it would have reduced. Yeah. Change that 0 to a 1. Well, any number divisible by 3, the sum of its digits is. So 2 and 7 is 9. 5 and 0 is 5. We're 1 short. Sometimes, not always, but yeah. So let's look at this here. Find the perimeter of rectangle A and B from the given information. So for rectangle A, we can find its perimeter. Perimeter of A. Well, we can add the sides together. 10 and 6 is 16. 16, 16 and 16 is. So the perimeter of A (32). The perimeter, the perimeter, perimeter. That's the only way I've been able to remember how to spell it. Is 32. Huh? Yeah, P-E-R-I, perimeter. Because if I don't watch it, I'll spell it with an E instead of an I. Yeah, so we can say the perimeter of A over, or sorry, perimeter of B over the perimeter of A is equal to 6. I'm sorry. It would be what? It wouldn't be 6. It would be over 6. So the perimeter of what we wanted is X over the perimeter that we know.
So it's like new over old. Yeah.
New over old is equal to new over old. So we want the perimeter of B is our X for now over the perimeter of A is equal to side length of B over side length of A. Now at this point here, we can multiply both sides by 32. These will cancel. 15 over 6 times 32 is 96. So the perimeter of B is 96.
So you said it would always be new over old.
Questions? We can look at another one.
Let's just look at 13. Yeah, look at 13.
So let's look at the next one here. Now, out of A and B, the only one we can find the perimeter of is B. So we'll find A eventually. B is the one we have. Now we can add them all together. So 20 and 30 is 50. That's 50, so together it is. So the perimeter of B is 100. Now we need to find the perimeter of A, yes? Now looking at these figures, will the perimeter of A be bigger or smaller than B? Smaller, because our corresponding sides are 30 and 5. About, yes. So X over 100. the perimeter of A over the perimeter of B, x over 100, would equal to side length of B over side length of A. Wait. I flipped those again. So perimeter of A over perimeter of B is what? A over B. I had those flipped for a second. Because since we put A on top, A's on top. B on bottom, B on bottom. We want to keep it the same. Does that make sense? Now the next thing we need to do is multiply both sides by. These will cancel. So we'll have 5 over 30 times 100 is 50 over 3. You're welcome. And I believe that's exactly what the back of the book or back of the review says, 50 over 3. 16 2/3. So 50 over 3 is 16.6 repeated, or 16 2/3. Second, $50 over 3 is the same as 16 2/3, is the same as 16.6 repeated. All those are the same. As long as it is the same answer, I don't care what form it's in. So if you want to leave it as 50 over 3 or convert it to 16 2/3, either one will work. Any questions on this here? Questions on 14 or 15. Determine if the following polygons are similar by angle, angle. If so, write their statement. So we need to find the missing angle. So for our first one here, ABC, well, we know one angle is 80, the other is, so if we add these together, we get 150 minus, subtracted from 180 is? No, because if we do this here, 80 plus 60 is? And 140 subtracted from 180 is? So these are not similar. Because for angle, angle, we need at least 2. Because we add the two, because the sum of any 3 angles in a triangle is 180. So I can add the 2 known angles together, subtract it from it 180 to find the missing angle. Yes.
Why is it not similar?
Because we have 80, 70, and 30. Here we have 60, 80, and 40.
Did you hear her?
So we need at least 2 angles to prove it similar by angle, angle. Since we only have 1, we can't say it's true. Now, if we look at the next one here, so I'll pick the top triangle here. So we can say 100 plus 54 is going to be 154. And if we subtract it from 180, 7, 6, so no. Because if we did 54 and 24, we can do that in a calculator. 54 plus 24 is 78. 180 minus 78 is 102.
So it's adding together.
Really, you're just finding the third angle and seeing if they're matching. Because once we know all 3 angles, and 1, 2 of them should match. If 2 of them don't, then it's not going to work. Yes. Now for this one here, these two angles are going to be congruent because they're vertical angles. Now since we do have a pair of parallel sides, angle A and angle D would actually be congruent because of alternate interior angles, because of parallel lines. Yes. So we could say that angle E is congruent to angle B, and angle D is congruent to angle A. Angle. Yeah. Because we're saying we're proving it by the angle property. Yeah. So we can include it, we don't have to. Now, for our similarity statement, we can say triangle what? ACB is similar. And it really doesn't matter how we start the first one out. We just need to state it. Just like with congruency statements, I just need to state one of the two figures. Yes. Now for angles here are congruent because the angles are congruent. But our triangles are not congruent, they are similar. Now our statement, we went A, C, B. Here we're going to go D, C, by angle. No, unless it says specifically to state the reason, we don't need to. So angles congruency, side similarity, similar, proportional. Any questions on 16 or 17? We good with these here? We ready to look at the next ones? The next ones are 15 through 18. Apparently whoever wrote this spaced out quite hard to go from and repeat 15 and 16. Yeah, it was. Past me, so different person. Now, looking at these here, show that the two triangles are similar and write the similarity statement. So when we look at these here, we either need two angles, an angle and two similar or proportional sides, or three proportional sides. Well, here, in the two figures, in this one and the bigger one, well, angle A is congruent to angle A. It's congruent to itself. Try it again. There we go. Now, we need another set of angles. Well, I know that this angle here is 57. All three of these have to add up to be. So we can add these together, 80 and 57. 180 minus 137 is well, that does give us a second set of angles that are congruent. So angle D is congruent to angle AEB. Because unfortunately at point E, we have more than one angle because we have the 43 and then this other angle down here, which is 137. 43 minus 180. Because they make a straight line. So, and yes, it seems very weird when I just throw it out there. So, when we say just angle E, we don't know which one of these two we're talking about. So if there's more than one angle at a point, we have to use the three letters. A, E, B. And it's just, as we went over it the first time, it's pretty much like you're tracing the angle vertex from point to vertex to point. So we do have two angles, so we can say triangle what? AEB. By similar, yes. Yep, similar. Triangle AEB is similar to triangle ADC by angle. Yes. This angle here and this one here would make a straight line. So they add together to be 180. We really didn't need the fact that it's 137. It poses no actual purpose. I was just putting it up there to signify that we do have two angles at this spot. Just name it angle E. Any other questions on 15 or 16? We're good with these here. 17 and 18. Now 17, it told us that angle M is congruent to angle X because we do have our little angle markers. Now these two angles are congruent because of vertical angles. L in M is congruent to X in Y, Y in X, either one, because they are the same angle. So we do have angle. So triangle M in L is similar to triangle X in Y by angle. M in L. Or if it's specifically saying show, then yes. If you're wondering tomorrow, ask. I will say if you need it or not. Yes. Huh. Yeah, you can write them on all of them because if you get it right, fine. If not, if you don't need it, it's not needed. Now it worked out 15 through 18 on all of these. These are all by angle. Because I kind of broke the review sheet up into its parts. Because here, determine whether JKL or RST, triangle JKL or triangle RST, is similar to ABC, triangle ABC, by side. So we're comparing them all of these to triangle ABC. So with this here, we can pick one of the two. So we can say 9 over 27, 15 over 45, and 21 over 65. Well, 9 over 27 is, because 9 goes into both, 1/3, 9 27ths. Is 1/3. 15 over 45, 1/3. 21 over 65. So close. So ABC is not similar to our JKL. So then we can do the same thing, but this time with 9 over 12, 15 over 20, and 21 over 28. 9 over 12 is 3/4, 3/4, and 3/4. So our correct triangle is triangle RST. Because we're comparing both of them to ABC, triangle ABC.
So will one always be?
Mm-hmm.
So if we get one wrong, we just automatically substitute.
Yeah.
Do we have to show our work on it?
As best you can. Questions on 19 or 20? Questions on 19 or 20? So 20 is the same thing.
I know, but like it's just doesn't.
No. It's the exact same thing. So we would say 2.9 over 8.41. Or, yeah, 8.41. Then we can say 2.4 over 5.76. And then 3.6 over 12.96. Plug them in and see, do we get the same number for all three? If we do, then they're similar. If we don't, then we do it with the other one. No, you're good. Because sometimes the decimals do throw us off, but they're not changing anything. So we can come back and look at it here in a minute. I do want to make sure we get through all of this here. Do we want to look at 21 or 22? 21 or 22? 22. So if we look at this here, we can use, say, x, if we need a proportion. Now I can use x minus 1 is over 8. Now I need to pick another side for our first triangle. 15 over 10. Because I picked x minus 1 over 8, because those match up. I would try to not pick the side that has x, that matches up to it, so 8 and 3 times x minus 1. Now at this point here, we can multiply both sides by 8. Now these will cancel. Now hopefully 15 over 10 times 8 gives us a nice number. 12. We can plug it in and see if it does give us a nice number. So that tells us 12. And the other one is x minus 1. Now we do just need to solve from here by. So x is 13. And if we look at the directions, it just says to find the value of x. That makes the two triangles similar. So the value of x is 13. We don't have to plug it back in. We're just finding x. Questions on any of this here? Yes. Okay. For 23. 22. 22. 22. I'll need to fix it. No, you're good. I just need to fix it. Because there's a good chance that it was wrong, and it is. So 22 is 13, not 12. Questions on these here before we look at 23 through 28? So we can look at 23 first. Now, for this here, we're given three sides that we're wanting to determine if the two triangles are similar. Show how they are similar and write their similarity statement. So when we look at this here, three sets of sides, we have to show that all three sets of sides are proportional. So I can pick a side here, say 5. Smallest side over here is 10, which is indeed 1/2. The next biggest side on the bottom triangle is 7. Next biggest one on top is 15. And last one we have is 9 over, which is, so are these two similar? Yeah. So we can say triangle EDF is similar to triangle. So since I started out at E, this congruent triangle would be SRQ. We could say by side, side, side. Yeah. If you're not sure on the test, ask. I will verify. Yeah, similarity statement. And if we're proving, it, I would definitely put Y. Yes. Yeah. So you can go on and go again, I would make sure to watch back, so if you have any other questions. So let's look at 25. So guys, let's look at 25 here. We want to show that these two are, we want to determine if these two are similar. Now, we do have three sets of sides, because one of them that we have is 10 and 50. They gave those to us pretty nice. Now, this side is 28, but the other side, we don't know, but the whole thing is 35, yes? It doesn't give us 35 minus, try this again, 35 minus 28 is, so this is 7. We can do the same thing with the other side and get 55 minus 44 is. So now we can compare the sides. So we could say 7 over, so this side over what? It wouldn't be 28, it'd be 35, because we're talking about the small triangle, the triangle inside, and the big triangle, the whole thing. We can also say 11 over 55, and lastly, we would have 10 over 50. 7 over 35. 11 over 55 is. 10 over 50 is. So can we say these two triangles are similar? Triangle what? ECD is I think what I heard. Yeah. PC what? PEC. PEC would work. Is similar to PAB. That's it. As long as it follows the same path, that's all that matters. Questions on these here? Any other one on 23 through 28 do y'all want to look at? 28. Because 28 is a little bit different because we are not given 3 sets of sides. We're only given 2 sets of sides, yes? Now, side angle side. Because these 2 angles are vertical angles. Because whenever we have 2 triangles that do intersect where their sides cross and connect, most likely we're going to have vertical angles. So we can say angle ACB is congruent to angle DCE. So we have a set of angles. Now we need the 2 sets of sides to be proportional, yes? Now the question is how they're going to match up. Well, one of the sides of the smaller is, the smaller side of the triangle on top is 25, yes? What side would go on bottom? Well, because 25 is the smaller of the 2 on top, yes? So we need the smaller of the 2 on bottom. They're going to be proportional, which means for the other one we have 43 over, so 25 over 32. So in the calculator we can say 25 over 32 is 25 over 32. This is not looking good for this problem. 43 over 56 is because for it to be similar, those proportions have to be proportional. 28 is indeed no. Yep. Yeah, so if these 2 had actually been proportional, the same proportion, then we can say they're similar by side angle side and write our statement. They're not always going to work. Any questions on any of these here? So if you have not turned some of your assignments in, I will give you till Thursday, end of the day Thursday, to turn them in.